Okay, so we are constructing geometry, then we're deconstructing geometry, then we're reconstructing geometry into something else. So the lecture I just gave you was about the fact that we used construct domain squared to reduce the size of these panels from their original frame, which was this, right? So it shrunk it down a little bit. So we have a new rectangular pattern that we're trying to create here, which has 4 corners plus a little midpoint. The midpoint's kind of tricky. That's why I didn't want to press you guys on that. But we have basically the same thing. Like we could just take that same panel and just reduce the size of it to create a domain down the bottom that's going to give us those 6 figures, or those 6 points rather. So let's just take a look at what that looks like. So it's exactly the same thing as what you have here, except what? What did we do here that we're not going to do again? Looking for the cleverest of the bunch to answer this.
Is it the -1?
Yes.
A minus B.
You are on fire today, one.
All right.
All right. So literally, we're doing exactly the same thing. Copy paste, yank it over, plug this thing in instead, and you can see that it just kind of did the same proportional subdivision. The only difference is we don't want to use the 1 minus whatever we reduced it by, because we want to change the proportions.
Are you recording this?
Yes, it's recording. Thanks for the reminder. Right. But we want to change the proportions of where these reductions are happening. So we have 2 of these. We're going to copy and paste those. And rather than, don't worry about the error right there, because we're going to increase the size here, increase the size there. So here is what we're doing. We have this additional panel that now needs to be reduced. And in fact, I think I kind of went over zealously on that. Only one of these we want to reduce, because one of them we want to keep. So this is the one that's going to centerize it, because it's the V domain, which is going north-south on the panel. This one is the one that goes side by side. So we do, in fact, want to keep the side-by-side one intact, because that's going to define centerization for us. So we'll get rid of this. We got a little over-ambitious there. Reduce this one. And so when you select this, what you're going to see is we're actually creating a little rectangle down the bottom. Something like that. Let's go there. Let's go in on north. And I actually want to reduce this depth. Leave it there. Okay, cool. So that is the rectangle we're going to create. You guys are going to create as well if you have a definition like this. So what do we do next? Huh? What?
You're gonna reference a point?
Yeah, we already wrote it. It's right there.
Yeah.
We did construct domain square.
So
Follow along, man.
Now you're gonna deconstruct.
Deconstruct BREP. Yes, precisely. So each one of these panels, we're going to go to surface analysis, deconstruct BREP. Right? That gets us the 4 corners. Right on. Now what do we do to find the other 2?
Math operator divided by division by, I guess, divided by 2.
No, because that's just numerical data. That's not a geometrical division. So what do we have at our disposal? We have
Evaluate surface.
Not yet. So we have faces, we have edges, and we have vertices. Which of those can we use to get the points in the center of this panel? If you were doing it in Rhino, how would you do it? If you had a face there, if you had edges, and if you had vertices, how would you do it in Rhino? Vertices? Yeah, or points.
Midpoints. Just use midpoints on the edges.
Yeah, you could use midpoints, but if you wanted a command to just find the middle point rather than trying to object snap to the middle point, you would use divide. What would you divide? The face, the edge, or the vertices? The edges. Thank you. So edges are found under curve, and you go to division, and I'm going to show you two ways of doing this. I think you guys are going to like it. So there's a division, which is going to divide a curve, right? And then we're going to go to edges. Actually, you know what? Let me stop this video where it is, because I'm going to get into like a whole other sort of logical sequencing thing. And we'll talk about subdividing edges in a new little chapter. Are there any questions on what I did with the subdivision first before we move on? Okay.